Yeah, this one's different too because it's not like equal. Or it's like different. You know what I mean?
They almost look parallel, but they're not quite.
Yeah.
I'm gonna try my best to draw that.
Find x.
So start to work through this one slowly, just on your end. And try not to distract you.
Okay, so do you think that we could just do this normally and then like subtract 5 or something somehow?
Like assume they're parallel and then just like adjust it.
And then adjust it because they're only 5 off. Like that would work, right?
It's an interesting thought, and I think it depends on exactly what you'd be aiming for. But I think what you're overlooking is that you actually do have 3 parallel lines on this.
Oh, okay.
Right? You do have that relationship to work with. It's just in a kind of rotated orientation of what you're used to seeing. Maybe we'll revisit that question and see if it makes sense once we get our answer.
Okay.
But looking here, you do have the 3 parallel lines, and what are they asking for again?
X and Y.
To find x and y, right? So not even to find an angle, but to find whatever x and y are in this case.
Yeah.
Okay. They give us some information. Does my diagram, just make sure I'm not going crazy here, does that look right to you?
I think that's good, yeah.
Okay, cool. All right, so what do we know?
We know 55 is equal to 5x minus 4y. And then 60 is equal to 5x minus or plus 5y.
Yeah, perfect. Besides this, just a little smaller. So you just said that 55 is equal to 5x plus 4y. And why is that, just for clarification's sake?
Why is that?
Yeah, like where did you glean that from?
Okay, because 55 in that equation is like complementary or corresponding.
Corresponding, yeah. That looks just like a problem you were doing before, right?
Yeah, because these lines are parallel, or these lines are parallel. So.
Exactly. It's just kind of like a two-parter here.
Yeah.
All right, so 55 equals 5x plus 4y, and then you also said that
60 is equal to 5x plus 5y.
Cool.
So I guess we should do one at a time, right?
Yeah, we could do one at a time. Well, you do have 2 variables in each equation, which means we will necessarily need 2 equations to solve for it. But just really quick before we jump in, let's assume x and y are some small positive numbers.
Okay.
We're not sure what they are yet, but 5 of the x's and 4 of the y's will combine to make 55.
5 of the x's, okay.
And then 5 of the x's, 4 of the y's, and then just one more y will combine to make 60.
Yeah.
So right away, without even really using algebra to its fullest extent, what can we probably say about the value of y if adding one y brings us from an angle of 55 to 60?
That's one less. That y is one less. Right?
There's one less y in this,
Yeah.
and what does it make a difference of? What's the difference
5.
between a 5?
So can we assume y is 5?
Y is probably 5. I'm going to write that at the bottom corner. Let's solve it the traditional way. But sometimes equations are just obvious, and you'd be like, oh, well, it's literally the same equation except for 1 additional y and 5 additional degrees.
Okay.
But let's see if we can solve it just by hand and see where that gets us. And this is going to be, this is solving a system of equations, which if you were kind of 50-50 on solving a single equation, then a system can sometimes be confusing. Have you done that before, where you solve for one variable and then plug it into the other equation?
I don't remember doing it.
Okay. Let me just run through it one time,
All right.
and then we'll this is a hard problem. We'll probably address this again and again in the future. Probably go about solving this problem. No, let's do elimination. If you haven't used either form, then let's use the one that's easiest on for this problem. And it's literally to take your two, it's elimination. You take your two equations and you literally subtract them from one another. And in fact, let's do it.
Okay.
Let's do it in the opposite order. Since I'm setting you up for perfect success anyway here, might as well make it super easy.
Yeah.
So you take your two equations, we're just going to subtract them from one another and get a new equation. That's just as equally true. So what is 60 minus 55?
5.
5 is going to equal, what's 5x minus 5x?
X.
If you have 5 water bottles and then you get rid of 5
it's
water bottles.
2x? Oh, okay. 5 water bottles and get rid of 5 water bottles. It's just nothing?
It's nothing,
Yeah,
right? You have 0 anything left, right?
Okay.
You got rid of everything. So that's just 0. And then what's 5y minus 4y?
1y.
Okay, what's y equal to?
Y is equal to 5.
5. Isn't that what we just said?
Yeah.
Down below. That was like one of the worst 5s I've ever drawn in my life. All right, so that wasn't that hard. That's a process called elimination. If you have two true statements, you can add them and subtract them together. It's going to make another true statement as long as you do the proper math, like the proper arithmetic here.
Yeah.
And if you do it with like a purpose, I did 5x minus 5x on purpose because I knew it would cancel out and get rid of my x's. This is like an algebra, end of algebra 1, beginning of algebra 2 technique.
Okay.
Okay, so you either learned it at the end of last year or you're going to learn it next year.
Yeah, that was like weirdly easy. I was totally bugging about this.
Yeah.
It's just
Substitution would have gotten us the same answer. It would have just been like
like
a lot more math.
stuff.
Anyway, we're in geometry class. We don't have to worry about that too much. But we know y is 5, so you can take over from now. If we know y is 5, also my eraser little tool came back and started working again.
Okay,
Isn't that
so
cool?
double click.
Yeah, it like stopped working for
That's
forever.
nice.
We know y is 5.
Yeah.
What is x?
X. Okay, so we should. Could we use the same like format?
In fact, you only need one of the. You can choose which equation, but you only need one.
Wait. Oh, okay. So can we like change this to like would we need to change the subtraction, or would we keep it subtraction?
Yeah, and you're confused because you haven't seen this technique before, right?
Yeah.
We had to use two equations at once
Yeah.
because we had two variables that were each unknown.
Okay.
Now that we know one of the variables, how many unknowns do we have?
1.
1. It's x. We don't know. We know y. We can plug in for it,
Okay.
but we don't know x. And if you only have one unknown variable, you actually only need one equation to solve it. So pick. Do you want to use this equation or do you want to use this equation?
Guess we'll just use the 55 one or 60.
Either one.
Yeah, we'll do the 60.
Okay, so go ahead and just write that maybe like here off to the
Okay.
side. So 60 equals 5x
Or could
plus
we
5y.
could we just
Oh, yeah.
like just move all this?
Yeah, I like that.
Tap. Resize. Short. Sick. Then back to this. Okay, so now we're just solving.
We're solving, right? But there's something we know
Oh, okay,
now that can
okay.
help us.
Okay, so that's a 25?
25. 5 times
Okay.
5.
Yeah. Oh, I just
So-
did that on accident.
You did that
I
on
really
accident.
wanted to. Okay, so then 5x plus 25. Right?
Yeah, that's looking good. 60 equals 5
5x.
times whatever x is
Yeah.
plus 25.
So we should get rid of. Or could we should we get rid of 25? I think we should.
X's to one side, numbers to the other. That sounds like a good strategy.
Okay, so minus 25. Minus 25.
Your hand can sit on the screen, by the way. Makes your life easier.
Yeah. I wasn't sure if yeah.
Then you just like start drawing handprints everywhere like turkeys.
Okay, so this just cancels out, and then do the blue thing, and then what's that? That's 35? Yeah.
35.
30. Oh my god. I'll just do it. 35 is equal to 5x. So
close.
okay, so now we get rid of the 5 or do we get rid of 35? Well, that wouldn't make sense if we got rid of 35.
Yeah, you do want to keep one x around. In fact, that's the end goal.
So
is to end up
so
with
minus 4?
You so you're
Maybe
thinking of
one?
subtracting 4 x's?
Yeah.
Yeah, you could subtract 4 x's and that would leave you with an x on this side, right?
Yeah.
And it would leave you with 35 minus 4x on this side.
Yeah.
And then suddenly you'd have an x on both sides.
Okay.
Then you'd have to undo it by adding 4x to both sides.
Oh,
It'd kind of be circular.
so I should divide this?
Divide by
5.
5, right? You have
Okay, so
5 of these little pizza slices. So we divide by the number 5 and that'll leave us with one single
Okay,
pizza
divide by
slice.
5, which is x, and this divide by 5 is, I don't know this one.
Yeah, you do.
You know
Just
this
kind of 5, 10,
10, 15, 20, 25, 30, 35. 7.
Seven.
Okay. So 7 is equal to x.
Seven
5 is
is
equal to
x.
5.
probably.
So now I forgot what we're trying to find. What are we trying to find? Just these angles? Just both of them? I
It
guess?
says in the problem.
Yeah. Okay.
No, it says reading the problem.
Just find x. Oh, we're already done.
Yeah, you did it.
Okay.
Right, we could if we wanted to.
Yeah.
I mean,
like figure those out.
what is 5 times 7?
5, 15, 20, 25, 30, 35.
35. And then what's 4 times 5?
5, 10, 15, 20, 20.
20. So what's 35 plus 20?
35 plus 20 is 45, 55.
55.
Okay.
Right?
Yeah.
Okay, and then let's just do
Oh,
the
they're
same
literally,
thing.
yeah. So we knew the whole time.
Yeah, we knew it the whole time. It was 55.
Oh, yeah.
That's how you solve for,
We're
that's
just-
how you
okay.
kind of formed the plan to solve for x in the first place.
Okay.
Cool.
Cool.
All right.
Yeah.
We're flying.
Shall we move on?